everyone, and welcome to MathSux. This video will help you pass the Geometry Common Core Regents. So we're doing this one question at a time. Here is question 25. Using a compass and straightedge, construct the angle bisector of angle ABC. So here's angle ABC, angle B, and we're gonna make an angle bisector. So we just need to, it's a couple of different markups. And I have a bunch of videos on constructions, a whole playlist actually, if you want to check those out. So we're going to take our compass and swing it, making sure it intersects with the other sides of the triangle. We'll bring the point to this side and make a mark, and then leaving the same distance, we're going to take the point to the other side and leave another mark. And now we're just going to intersect the cross section with our angle B and draw a line. And that's our construction, our angle bisector. Question 26. On the set of axes below, triangle ABC and DEF are graphed. Describe a sequence of rigid motions that would map triangle ABC onto DEF. So already you can see it looks like we're doing a rotation clockwise about the origin. So a 90-degree rotation clockwise about the origin. So for this question, just be careful, be sure to mention that it's about the origin, because things could be centered at different points. So we want to make sure that it's centered about the origin. So if we were to graph what our new triangle would look like once it's rotated, it would look something like this. So you can either visualize this, or you can use the rule to change the coordinates. So this question doesn't require you to do this, but if you want to visualize what motion would come next, just keep this rule in mind for moving coordinates 90 degrees clockwise about the origin. So originally we have these coordinates, and then when we do a rotation of 90 degrees clockwise, or minus 90 degrees, the rule is that it now becomes y comma negative x. So we're switching the x and y values and negating the x. So a prime becomes 5, 1, b prime becomes 1, 1, and c prime becomes 1, 3. So now we have our actual answer is over here. 90-degree clockwise rotation about the origin, and then the next step you could see that we just translate over 1 unit and then down 1, 2, 3, 4, and then down 1 unit. So we have translate, right 1 unit, and down 4 units. So our answer is right here, and we don't need to actually find the next coordinates because we know it can line up by looking at the graph. So it's 4 units down and 1 to the right. But for this question we just need to have this 90-degree clockwise rotation about the origin, and then translate right 1 unit and down 4 units. Question 27. As shown in the diagram below, a symmetrical roof frame rises 4 feet above a house and has a width of 24 feet. Determine and state to the nearest degree the angle of elevation of the roof frame. So since this is symmetrical, we could kind of just cut this in half and realize that over here we have our own triangle with this side being 12 feet and this being 4 feet. So I'm just going to draw that down here. And what we're looking for is the angle of elevation, which is this right here, this angle. So we have 12 feet here, 4 feet here, and then we're looking for this angle of elevation, this theta. So if you look at our SOHCAHTOA of what information we have the opposite to this angle and the adjacent to this angle, which would be tan. So we have tan of theta is equal to the opposite, 4, over the adjacent, which is 12. So to find what angle this is, we're just going to do tan, or arctan of 4 over 12, and then we could just plug this into our calculator and see what we get. So second tan 4 divided by 12, and we get about 18 degrees. And they wanted it to the nearest degree, so we could just leave it as 18 degrees. Question 28. Directed light segment AB has endpoints whose coordinates are A, -2, 5, and B, 8, -1. Determine and state the coordinates of P, the point which divides the segment into the ratio 3 to 2. So here there's a nice little formula we can use to find this coordinate they want for X and for Y. So we're going to be doing the formula 2 times. So let's just write out all the information we have. We have A is -2, 5. We have B is 8, -1. And then we have this ratio 3 to 2. So these are all the numbers we're going to be working with. So to find the X value to divide the segment into this right ratio, we're going to be using this formula. X equals X sub 1 plus A over A plus B times X2 minus X1. So let's just label our information up top. This is the X1, Y1, X2, Y2, and then our ratio is A to B. So now we're just plugging this in. So X1 is -2 plus A is 3 over A plus B, 3 plus 2 times X2, 8, minus -2 X1, which is plus 2. And then we could just plug this into our calculator. This is 10 times 3, which is 30, divided by 5, which is 6. So we get -2 plus 6. So we get X is equal to -4. This is part 1 of our answer. And now we're going to do the same thing with the Y values with the same formula. So instead of X's though, we're dealing with Y. So we have Y1 plus A over A plus B times Y2 minus Y1. And this will give us 5 plus 3 over 3 plus 2 times -1 minus 5. So this will come out to 1.4. So the other part of our answer, we get Y is equal to 1.4. So we just need to put this all together into one coordinate point. So where X is -4 and our Y is 1.4. And that's our answer. Question 29. Triangle ABC, AB is equal to 5, AC is equal to 12, and angle A is equal to 90. So let's just draw this out. So that they said angle A is 90 degrees, AB is 5, and AC is 12. And then they give us another triangle, triangle DEF, where angle D is 90 degrees, and then DF is 12, and EF is 13. Brett claims that triangle ABC is congruent to triangle DEF and triangle ABC is similar to DEF. Is Brett correct? Explain why. So you can see that there's a missing side here, so we can just solve using the Pythagorean theorem for that missing side. Or you could recognize that this is Pythagorean triples and these are going to match, but I'll just do this the long way. So we get 13 is equal to the hypotenuse here, which matches this. And then here we have B equals 5. Okay, so we see that they have side congruency. So Brett is correct. So by side, we know that these triangles are congruent and they're similar. So if they're congruent, they're going to be similar also. So we know if it's one, it's going to definitely be the other. And that's our answer. Question number 30. The volume of a triangular prism is 70 inches cubed. The base of the prism is a right triangle with one leg whose measure is 5 inches. So I'm just going to sketch this out. We know this is a right triangular prism. So something like that, 5 inches. So one side of this is 5 inches. So we'll say it's this way, and then it says the height is 4 inches. If the height of the prism is 4 inches, determine and state the length in inches of the other leg of the triangle. So we know that the volume of this shape, the right triangular prism, is equal to 70 inches cubed. So to calculate that, the formula for that is 1/2 base times height times length. So we know it's equal to 70, and we're going to need to find this missing here. So I'm just going to call it b. So b times the height, which is 4, times the length, which is 5. We're going to get 70 is equal to 10b. Divide 10 on both sides, and we get 7 is equal to b. Question 31. Triangle ABC with coordinates -2, 5, 4, 2, and -8, 1 is graphed on the set of axes below. Determine and state the area of triangle ABC. So the first thing we're going to want to do here is draw a rectangle around our triangle. So what we now have is a rectangle, and we could find the area of it and then subtract out the negative spaces. So we have the area of the rectangle, so let's count how many units are in here. 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12. So we're going to have 12 by 1, 2, 3, 4, 5, 6. So the area of the whole rectangle in here is 72. Now notice this also created these negative space triangles. A triangle here, 1, 2, and 3. So what we're going to do is find the areas of each of these, add them up together, and then subtract it from the rectangle. We'll be left with what's of triangle ABC, the area of what's left. So if we find the area of triangle 1, we have 1/2 times the base, 1, 2, 3, 4, 5, 6, times the height, 1, 2, 3, 4, 5, 6. And when we calculate that, we're going to get 18. The area of triangle 2, we're going to have 1/2 times 1, 2, 3, 4, 5, 6, times 1, 2, 3, which will give us 9. And the area of triangle 3 is 1/2 times 12 times 3, which will give us 18 again. So now we're going to take 72, the area of the whole rectangle, and then minus 18 plus 9 plus 18. And when you plug this into your calculator, we'll get 27. Question 32. Sally and Mary both get ice cream from an ice cream truck. Sally's ice cream is served as a cylinder with a diameter of 4 centimeters and a total height of 8 centimeters. Mary's ice cream is served as a cone with a diameter of 7 centimeters and a total height of 12.5 centimeters. So they show both of these. They already have diagrams for us, which is nice. Assume that ice cream fills Sally's cylinder and Mary's cone. Who is served more ice cream, Sally or Mary? So this is a volume question, and we just want to compare and see which holds more ice cream, the cone or the cylinder. So first let's write out the volume of a cylinder, which is pi r squared h. And here our radius is going to be 2, so we have pi 2 squared times the height, which is 8. And we plug this in, and we get 100.530. Now we find the volume of the cone, which is 1/3 pi r squared h. So notice it's the same, but now we're just multiplying times a 1/3. We have different numbers to plug in here. So we have 1/3 pi, the radius is 3.5 squared, times the height, which is 12.5. So plug this in, and we get 160.352125. So you could see that the cone, Mary's cone, will be able to hold more ice cream. Based on the volume. So the second part of this question says, determine and state how much more is served in the larger ice cream than the smaller ice cream. So we just need to subtract here how much more ice cream is Mary going to have compared to Sally. So we want to show our work, so we're just going to write it out. So we're just taking 160.352125 minus Mary's ice cream volume, which is 100.5309649. And it said to round to the nearest cubic centimeter, so right now it's 59.8, but to the nearest cubic centimeter it's going to be 60. Question 33. Given triangle AEB and triangle DFC, ABCD is a line, AE is parallel to DF, so AE is parallel to DF, EB is parallel to FC, EB parallel to FC, and AC is congruent to DB. So AC is congruent to DB over here. Prove triangle EAB is congruent to FDC. So let's mark this up a little bit and make a plan for our statements and reasonings. So we can see that we have some parallel lines, so cut by this transversal. So because of that, angle A is going to be congruent to angle D based on alternate interior angles. We also have these other pair of parallel lines, EB and CF, and that's going to give us this angle, EBA, is going to be congruent to angle DCF. And this will be based on exterior angles. So this is, related to those transversals. When two lines are parallel and it's cut by a transversal, we get all these different angle relationships. So we have an angle. So now, so another feature they told us about was AC is congruent to BD. So because of that, we can see that they share in the line this BC here. So we could say that BC is equal to BC by the reflexive property, and then by the subtraction postulate we can say that AB is going to be congruent to CD based on the subtraction postulate. So if we look at what we have here, we have an angle, a side, and an angle, or ASA. So we're going to be proving these two triangles congruent to each other by angle, side, angle. So now that we have a plan, let's start writing out our statements and reasonings. And if this doesn't make sense to you, we're going to do this one step at a time still, so don't worry. We're going to write everything out, and hopefully it'll come together as we go along. So the first thing we're always going to want to do with our proofs is just write out everything they gave us. And our reasoning for this is that it's given. This is always our first easiest step. And next we can do our angles that we found. So we have angle A is congruent to angle D. And we know that because of alternate interior angles. Next we can do our other set of angles. Angle EBA is congruent to angle FCD. And this is the same idea, but this time it's alternate exterior angles. Now we can mention BC and the reflexive property. And based on AC being congruent to DB, what they gave us over here, and the reflexive property, so we have this listed up here in the given, AC congruent to DB, and then we have the reflexive property. We know by the subtraction postulate that AB must be congruent to CD. And finally, we can prove our triangle is true by angle side angle. So also, if you're a little confused by the alternate interior angles versus the alternate exterior angles, because it could be a little hard to visualize, if we look at these separately, so if we look at, so this is our transversal, this line ABCD, and then if we look at this here, where angle A is over here, and then D is over here, we could see that these are alternate interior angles. And the same thing can be done the other way, where this is our transversal again, A, B, C, D, and then the parallel lines we're working with are EVA, so this is angle B over here, and then over here we have angle C, so you can see that they're alternate exterior angles outside. Question 34. Barry wants to find the height of a tree that is modeled in the diagram below, where angle C is a right angle. The angle of elevation from point A on the ground to the top of the tree H is 40 degrees. The angle of elevation from point B on the ground to the top of the tree is 80 degrees. The distance between points A and B is 85 feet. So far they're just summarizing what is in the picture here. Barry claims that triangle ABH is isosceles. Explain why Barry is correct. So let's see if we can find out if this triangle ABH is isosceles. So if we can play around with the angles here, see how this 80 degrees is an exterior angle, so we know over here this is going to have to add up to 180. So if it has to add up to 180, we know this is going to be 100 degrees over here. And that means 40 degrees would be over here. So because these angles match, we know that this is going to be an isosceles triangle for triangle ABH. So we can say, yes, Barry is correct. I probably don't have to write as much as I did, but I wrote, yes, Barry is correct because triangle ABH has two interior angles of equal value, 40 degrees, and an isosceles triangle has two congruent angles. So because these are congruent, just a note, we know that this side is also going to be congruent. So this is 85 feet, and we know that this is also going to be 85 feet. So knowing that will help us to answer the next part of our question, determine and state to the nearest foot the height of the tree, X. So we're going to be focusing on this smaller triangle here. So I'm going to draw it down here. So we now know that this is 85, the hypotenuse, and we have our angle 80 degrees down here. We want to find this missing side length of the tree. So to do that, let's look at SOHCAHTOA and see what information we have. According to this angle 80, we have the opposite and the hypotenuse. So we're going to be using sine. So you know sine of 80 degrees is going to be equal to the opposite x over 85, the hypotenuse. So just doing a little cross multiplying. Now we can multiply 85 times sine of 80 to get x. And we could just plug this into our calculator. And we end up getting 83.7086, and it keeps going. But if you look back at our question, they wanted it to the nearest foot, so we know that we could just say this is 84 feet. because we're going to round up because of the 7. And that's our answer. Not so bad. Question 35. Given triangle DUC with coordinates D, -3, -1, U, -1, 8, and C, 8, 6. Prove triangle DUC is a right triangle. So I'm just going to sketch this out. It doesn't have to be exact. So we have our triangle DUC, we sketched it out. And now the goal here is to prove that DU is perpendicular to UC, because this looks like a right angle, right? And we're going to do that by showing the slopes of DU and UC are negative reciprocals of each other. So if they're never negative reciprocals of each other, that means they're going to form a right angle. So we have DU is -3, -1, and -1, 8. And then we're just going to find the slope, which is the change of y over the change in x. So if we have 8 plus 1 over -1 plus 3, we're going to get 9 over 2. So now let's find the slope of UC. U is -1, 8, and C is 8, 6. And we're doing the same thing, change of y over the change of x. And we end up getting 8 minus 6 over -1 minus 8, which is going to give us 2 over -9. So notice we have negative reciprocals of each other, 9/2, and then the negative reciprocal of that, we flip and negate it to get 2 over -9. So we know that DU is perpendicular to UC, and therefore form a right angle. And therefore we can conclude that triangle DUC is a right triangle. Point U is reflected over DC to locate its image point U prime, forming quadrilateral DUCU prime. Prove quadrilateral DUCU prime is a square. So to do that, let's first graph our coordinate points that we do have. So if we look back, actually let me just rip this off so we can just look at our coordinate points like that. So we're not making a triangle though, we're making a quadrilateral. But to do that, it's going to be point U, we're going to be reflecting point U over the line DC. So let's draw the lines of the triangle we were working with. It says point U, so this point over here is reflected over DC, this line here. So we want to like end up over here somewhere to form this quadrilateral. So usually I would just count how many are over, but it's kind of, if you look at this, it's kind of hard to find where the middle value is here along this line DC. So what I'm going to do is find the midpoint of line DC. So to find the midpoint, we're just going to take the coordinates and the of D and C and then average them. So if we know D is -3, 1 and C is 8, 6, we know that we can just take the average of these. So we're just going to add the x values and then divide by 2, and then we're going to add the y values and divide by 2. So we end up getting 2.5, 2.5. So if we find that on here, we have 2.5 and then 2.5. So that's this point right here. So now it's going to come the visual part, and we're going to see how many units from U we're going to go down to get to this point. So if we go down 1, 2, 3, 4, 5 units, actually 5.5 units, we're going to be going down 5.5 units and to the right 1, 2, 3.5. So, and then to the right 3.5 units. We're just going to do the same thing on the other side of the square to find the reflected point U prime. So we're going to go, here's a half, and then 1, 2, 3, So we know that we're doing 3.5 units to the right, and then we're going to go 5.5 units down. So here's a half, and then we need to go 1, 2, 3, 4, 5. 5.5 units down. So we end up with u prime down here at this point 6 minus 3. And when we add our lines in, we'll see if this looks right, because we could always check ourselves visually. Because we want to prove this is a square. So does this look like a square? Yes, so we reflected the right way, we got our new point, and now we can focus on proving that this quadrilateral is actually a square. So to do that part, we're going to be using the distance formula and making sure each side of the square is equal. So the distance formula, a reminder, is radical x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And now we're just going to check each side. So let's start with side UC. So U has the value -1, 8, and C has the value 8, 6. And now we could just plug this into our formula. Okay, so we have UC and we get that it's equal to radical 85. Okay, so let's try the next one, side UD, where U is -1, 8 and D is -3, -1. So again, we get radical 85, which is good. So we know we're on the right track. Okay, let's try another side, side DU. DU prime, sorry. And we get radical 85 again. DU prime over here. And our last side, side CU prime. And this too comes out to radical 85. So we know that this is a square because all sides are equal. And we also prove that this angle U here is a right angle. So now we just need to write a little sentence to sum up what we found. So since all four sides of a quadrilateral DUCU prime are congruent and angle DUC is a right angle, DUCU prime is a square. So this was our last question on the test for reviewing. I have more geometry tests that I go over also, so please look out for those playlists. Good luck and happy calculating. So if you're looking for more on this test, check out the playlist in the link below. And thanks for stopping by. Happy calculating. Need more practice? Check out MathSux.org for more questions. Link below. Also, don't forget to subscribe. Happy calculating!